Hi there, I'm Mrs. Seaholm, and I'm going to be going over some triangle proofs today. This won't necessarily be an exhaustive list of proofs that you might see, but it's certainly a start. Okay, so the first proof we're looking at here, we've got given segment AD is congruent to segment CD, and also segment DB bisects angle CDA. So ideally, I would be able to mark on the drawing itself, but I can't because it's a Word document and it's not going to allow me to do that. So I encourage you to do your own drawing, either like on a Google Drawing or on paper, really. I think paper is probably the best to do. So I'm just going to mark what information is given first. So I'm going to use 1 dash to indicate that AD is congruent to CD. So I want to indicate with a curve that angle ADB here is congruent to, let me just change the color, congruent to angle BDC. So this angle here. So those angles are congruent. And we know that because, let's just reference our pink sheet here. Now, the first page is basic algebraic properties and laws of algebra. It's probably not where we want to look. Segments and angles, maybe that's what we want. Now, we do have in our given statement something about bisecting an angle. So I'm going to look for angle bisector. So definition of angle bisector right here. So angle bisector right here. And what that says is that if something bisects an angle, then the two angles that are created are congruent to each other. So that's what I want to use. So that is definition, let's abbreviate it, of angle bisector. Okay, now the next one doesn't necessarily follow from the previous statement. However, if you look at it, if you look at the statement, segment BD is congruent to itself. Now, when things are congruent to themselves or equal to themselves, we're looking for up here the reflexive property of congruence. Now, the reflexive property of equality is for when things are equal to themselves. When things are congruent to themselves, it's a reflexive property of congruence. So we'd write reflexive property of congruence. Go back to our drawing here and mark that. So we want something congruent to itself. And I need to use 2 dashes this time because I already have the 1 dash taken. Let me choose the color so it's color coordinated here. So BD is congruent to itself, right? And then if we look and we compare triangle ADB with triangle CDB, we can see that they have 2 sides and an included angle, 2 sides and an included angle that are congruent. And so we would say by SAS, because that's 2 sides, S's, and then the included angle, the A is in between the S's. So that would mean that the triangles are congruent. And then when we have congruent triangles, when we're comparing corresponding parts after that, we have angle ABD, that's this one right here. That is congruent to angle CBD, that's right here. So those are corresponding parts of congruent triangles. So we'd say by CPCTC, those angles are congruent. Corresponding parts of congruent triangles are congruent. Okay, so then for number 2, I've already started my drawing here. I'm given that AB is congruent to DC, so I want to mark that. We also have that AD is congruent to BC. So that is our given information. We already have 2 sides of one triangle with 2 sides of the other triangle. And that is our given information. So as always, our first reason is given. And then we have that segment BD is congruent to itself. So if you'll remember from the previous one, that would be the reflexive property of congruence. When something is congruent to itself, that's a reflexive property of congruence. So I'm going to go ahead and fill that in. And I want to mark it on my diagram here. It's kind of silly, but when we mark things congruent to themselves, it just helps visualize the reasoning why two triangles are congruent to themselves. So if you look at triangle ABD and triangle CDB, the first side, AB, is congruent to the first side here, CD. And then if we move to the shared side, BD with DB, and then finally DA, BC. So we can say that those triangles are congruent because all of their sides are congruent. So that would be SSS, side, side, side. And as a reminder, these are on your pink sheet. So if you're looking for triangles, that's the last page. And you can find side, 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 side angle, side, ASA. That should be AAS. Then it has all of these things for you. And to make it a little bit easier, hopefully for you, you can view the document outline, and that gives you the titles. So the section and the title of each of these, so that you can just like go straight to something if necessary. Okay, so SSS, side, 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 gives us that those two triangles are congruent. And because the two triangles are congruent, the angle 1 and angle 3 correspond to each other, and they are congruent. So CPCTC. Corresponding parts of congruent triangles are congruent. All right, so number 3, we're given angle A is congruent to angle D. So I've marked that here. And then it says that B is the midpoint of segment CE. So obviously, because that's the given statement, we write given for the first reason. And then typically after we have a statement about a midpoint, we're going to want to use that. So if we look at our pink sheet here, and I'm looking for something about a midpoint. So I'm going to look over here, and sure enough, definition of midpoint says that if you have a midpoint of a segment, then the two segments that are formed are congruent. So I'm going to use that. So I have EB is congruent to CB, and I'm going to mark that on my drawing here, EB and CB. And then I might notice, well, okay, I've got an angle and a side, angle and a side, but I have two intersecting lines creating vertical angles. We know that vertical angles are congruent by the vertical angles theorem. So indicate which angles are congruent to each other. Now, remember, we can't just say angle B and angle B because that just sounds like itself. So we have to be specific. So in order to indicate this angle here, we use ABE. And we want to note that that's congruent to angle DBC. Okay, and again, that's the vertical angle theorem. So just to double check, vertical angles theorem says if two angles are vertical, then they are congruent. So, all right, now one more step before I can prove that angle E is congruent to angle C, and that is to say that my triangles are congruent. So looking at my figures, I have two angles and a side. That side is not included in between the two angles. And so that would be angle, angle, side with angle, angle, side. So ABE is congruent to triangle DBC. That's by AAS. And now that I have two congruent triangles, their corresponding angles are congruent. So that would be CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so we're going to continue with number 4, which says, given angle 1 is congruent to angle 2, I'm going to pause to mark that. Angle 1 congruent to angle 2. And AC is the bisector of BD, we want to prove that angle B is congruent to angle D. So the first thing we do is restate the given information and say that it's given. So given. Okay, so as far as the first part of the statement, that might not help us much for the very next statement, but when we have a segment or ray or anything that's a bisector of a segment, we're probably going to want to go with that. So if we go back to the pink sheet, the definition of a segment bisector says that a line, segment, ray, or play is a segment bisector if and only if it intersects the segment at its midpoint. So we probably want to use the definition of segment bisector to say that C is the midpoint of segment BD. And then from there, we can say that because C is the midpoint of BD, BC is congruent to CD. So that would be right above definition of midpoint. If you have a midpoint of a segment, then each of the pieces of that segment are congruent to each other. Okay, so I'm going to mark that BC and CD are congruent. And then here's a hint. The next reason is reflexive property. So reflexive property, remember, is when something is equal to itself or congruent to itself. In this case, if we see the two triangles share a side, we're probably going to want to talk about that side. So segment AC is congruent to itself by the reflexive property, and here it should say of congruence. And that's, I'm going to abbreviate it so it doesn't take more than one line there. So in IXL, you're going to see reflexive property of equality versus reflexive property of congruence. So know that there, when you are talking about congruent things, you want to use of congruence. Okay, so segment AC is congruent to itself. So now we have side and side with included angle, congruent to side, side with included angle. We can say triangle ABC is congruent to triangle ADC. And remember that the order of the letters does matter. We want the corresponding vertices to match up. And then because we have two congruent triangles, then their corresponding angles, B and D, will be congruent to each other. And notice that B and D are both the second letters of each of those triangles in the congruent statement. So I can say then that, right there, angle B is congruent to angle D. Okay, so number 5, we're given that angles 1 and 2 are congruent, and then also angles B and D are right. Okay, so I'm going to go ahead and enter my given information here. All right, now one thing that we know about right angles is that they measure 90 degrees, and so they're congruent. There's actually a right angle congruence theorem. If two angles are right, then they're congruent. So I will say that angle B is congruent to angle D. The right angle congruence theorem. And so we can use squiggles to show that they're congruent as well. Okay, so we've got, it's a little bit messy, but we've got two angles in one triangle congruent to two angles in the other triangle. We're just missing a side. So we notice that the side along the center is shared between the two triangles. So segment AC is congruent to itself. And when things are congruent to themselves, it's like they're looking at the reflection in the mirror, so the reflexive property. So by the reflexive property of congruence. And then now we have two angles and non-included side with two angles and the non-included side. I know that's a non-included side because the included side would be AD and AB, right in between those two angles. So I would say triangle ABC is congruent to triangle ADC by angle side. Okay, for the final example, we have given segment CA is congruent to segment DA and angle C is congruent to angle D. Prove that triangle BCA is congruent to triangle EDA. So first off, we're going to enter the given information because that's always where we start. And we mark up the information as well. So CA is congruent to DA, and angle C is congruent to angle D. Okay, and now the only thing we're missing is either another side or another angle, or another pair of sides or another pair of angles congruent, and then we can say that the triangles are congruent. So luckily we have two intersecting lines that form vertical angles. So we can use the vertical angle theorem to say that those angles are congruent to each other. CAB, and I start with C because that's the angle that's marked. CAB, and then I know which angle I'll start with later. DAE, it's congruent to. And now we have angle, angle included side angle, angle included side angle. And we do want to use the statement that we wanted to prove. So just to double check, B corresponds with E, right? B corresponds with E, so those are the unmarked angles. C corresponds with D, those are the angles marked with one arc. And then lastly, the angles at A are marked with two. So that would be angle, side, angle.